Good evening, my dear students. Welcome to the reputed platform Unacademy, my dear students. Once again, before entering into the subject and the details, my wishes, New Year wishes to all the students of the South India, my dear students. Okay, so before entering into the subject, okay, this year is going to happen the beautiful year for all the students. Okay, as far as okay, the Unacademy Telugu channel is concerned, my dear students. Okay, so let me entering into the subject. Let me depict you about myself. Myself is Dr. B.N. Rao, having 17 years of the pure teaching experience. Out of that, from the last 10 years, I was supposed to be teaching the various subjects like communication systems, core instrumentation, electronic device and VLSI design, my dear students. Okay, in the departments of electronics and communication engineering and instrumentation engineering for the competitive examinations like GATE and engineering services. Okay, nearly I dealt 200 plus batches across all the locations of the India, covering the northern and southern parts of the India. Okay, not only I delivered the various subjects in the departments of EC and instrumentation, my dear students, the very important thing itself is that okay, the important parameter itself is that I delivered and mentored the webinars and the seminars throughout the India, mentoring the nearly 10k plus students across all the locations of the India, my dear students. Okay, this is about my brief profile. Similarly, okay, and recently last year itself I have received the PhD, which is one more biggest achievement in my career. Okay, from the Department of ECE under the specialization of low power VLSI design, my dear students. Okay, similarly, okay, the very important things just I would like to bring it to you as far as the Unacademy is concerned. Unacademy is having its own reputation not only over the country, in the international market also, my dear students. Okay, the subscription wise, if you are going for the two subscriptions plays a vital role. One is the iconic subscription and second one is the plus subscription. Okay, if you are going to take it the iconic subscription, my dear friends, a personal coach is dedicated for each and every student. He will depict you his subject in a detailed manner, starting from the basics to the till and followed by the model problems and gate problems with a detailed study planner, my dear students. Okay, moreover, you are going to receive the expert guidelines from the topmost educators of the Unacademy when you are going to take it this particular subscription. Okay, and moreover, okay, when comes into the okay engineering services level, you are going to get the well guidance and well, that is subject conceptual knowledge and the problematic knowledge and conventional knowledge as far as the two stages like stage 1 and stage 2 are concerned, my dear students. Okay, this is about the iconic subscription. Okay, similarly, when comes into the plus subscription, when you are going to take this particular subscription, my dear friends, you are going to access the live classes from the topmost educators of the Academy in whatever the language you are quite interested, whether it will be okay, whether it will be okay English, or it will be Telugu and English, or it will be Hindi and English. The topmost educators are there inside the Academy subscription. They are going to depict you the subject in a detailed manner. Okay, but when comes into the nowadays, the vital role is played by this test series, my dear students, because today's all the examinations becomes the online examinations. Okay, so to keep that particular perspective into account, so online test series, okay, we are, as far as Unacademy subscriptions are conducting the best that is test series, so that each and every student who are going to appear the examination, my dear students, so that each and every student will get the confidence level such that we will train you in the form of the test series, my dear students. Okay, similarly a structured timetable is also present over here, my dear students, when comes into this particular subscription. Okay, similarly when comes into the gate and engineering services, for plus subscription is concerned, the fee structure details, my dear students, for 12 months 27,225, for 18 months for the same plus subscription 34,650, for 24 months the fee structure is 39,600, and you can use my code and get the discount, my dear students. Okay, this is as far as the plus subscription is concerned. Okay, similarly when comes into the iconic subscription, my dear students, iconic subscription, for this particular subscription for 12 months the fee structure is 45,225, and you can use my code and get the discount. For 24 months the fee structure is 66,600, and you can use my code and get the discount, my dear students. Okay, similarly, so already the biggest ever surprise for all the South Indians is waiting, my dear friends. That is okay, the New Year gift is going to announce okay soon, my dear friends, at 5 p.m. Okay, please after the class, please stay tuned for this particular session also, my dear students. Okay, very very important one. Okay, similarly the plus batches taken by the inside top educators for electrical and ECE. Okay, that is target engineering services prelims 2021 batch D, and rank booster batch for gate 2021 batch D, and target engineering services prelims 2021 batch C, and rank booster batch for gate 2021 batch B. All these batches already started and it is running successfully. So some batches in the November and some batches in the December, my dear students. Okay, similarly there are certain batches that has been started in the last week of the last year. Okay, that is Ascent for gate 2023 ECE batch A. It will be taught in English and Hindi, starts on the 21st of the December, my dear students. Okay, similarly Ascent for the gate 2023 electrical batch A, English and Hindi, my dear students, starts on the 21st of the December. Okay, the last week of the last year, means only the 10 days back. Evolve for the gate 2022 electrical batch A, which is English and Hindi, my dear students. Okay, similarly evolve for the gate 2022 EC batch A, which will be taught in English and Hindi, my dear students, starts on the 21st of the December, my dear students. Okay, similarly the gate crash course, as far as okay that today's okay, so in this particular month also going on similarly, my dear students, but from this particular month onwards, my dear students, the crash courses okay, and the subjects that are going to tell in this particular channel is purely in English, my dear students. Okay, good evening Shiv Kumar, happy new year. Similarly the crash course for the EDC also remains as usual in this particular month, my dear students. Finally, these are all the general things that I am going to bring it to your notice, my dear students. Okay, and similarly, the concept wise, almost all I have cleared, my dear students, in the previous class regarding the starting of the noise, my dear students. Okay, noise already started. Okay, I told you in the previous class about the noise parameters. Okay, noise analysis, my dear students. Noise analysis, my dear students. Okay, what is generally noise? Any unwanted signal. Okay, my dear students, which is always causing interference to the required signal. Okay, if you are going to take any unwanted signal which is causing the interference to the required signal is called noise. Okay, that is in terms of, suppose this is a particular receiver. I told you in the previous class, my dear students, this is a receiver. in this particular receiver, if any, what I'm going to tell you itself is that this is the transmitter via channel. I told you in the previous class, see here the signal is transmitting, the signal enters into the channel. In the channel what is present? Noise is present. The signal is contaminated with what, my dear students? The signal is contaminated with noise, my dear students. Okay, then automatically what happens? The signal power is reduced. Okay, the signal power is reduced, my dear students. Okay, then automatically when the signal power is reduced, means here what happens? Any unwanted one, okay, that is interfering the required signal. This is a unwanted noise, my dear students. Okay, that is interfering with the required signal, which is called noise, my dear students. Okay, how many types of noise I told you in the previous class? Two types of noises are there. One is called external noise and the second one is called internal noise. So I told you in the previous session regarding the external noise, means the noise which is generated outside the system. Okay, naturally, my dear students, is called external noise. I told you in the previous class, go for the previous recordings, and the noise which is generated inside the system is called internal noise, my dear students. Okay, and external noise, I told you, my dear students, different types are there. Atmospheric noise, okay, due to sudden thundering or sudden lightning, my dear students. Okay, this kind of noise you are going to get. Okay, second noise is called cosmic noise. Okay, the radiation from the stars, that is stars. Okay, third one itself is called cosmic noise, so that is the solar noise. Okay, means the radiation from the sun, my dear students. Okay, and the fourth noise itself is very important, is called the industrial noise, my dear students. Okay, and this noise you are going to get from the radiation from the electrical equipment or the industries, my dear students. Okay, already I have completed about these particular parameters in the last class, my dear students. Okay, similarly internal noise. Okay, what is internal noise? Means the noise that is generated inside the system, my dear students. Okay, inside the system. Okay, so apart from these particular noises, there are different other types of noises are there. Okay, what are those noises? Means suppose you are going to bring back any mobile, okay, to any particular TV, then what happens? The TV picture is going to be distorted. The TV picture is going to be distorted because of the these particular radiation, because of the phone electromagnetic radiation, my dear students. Then automatically what happens? The picture in the TV itself is going to be distorted for a missing for a small interval of time. It is missing for the smaller interval of time, my dear students. Okay, which is very important parameter. Okay, say this is very important. Okay, and these sources are not considered. Okay, and whatever the noise I told you, and these sources are not considered while calculating the signal to noise ratio, because these sort of noises will occur only for the limited interval, very small interval of time, my dear students. Okay, very small interval of time, my dear students. But here, that's the reason we are considering the noise. Okay, maximum amount of the noise which is occurring here, my dear students. Okay, and that particular one itself is called the internal noise, my dear students. Okay, internal noise. Okay, means this noise is created inside the system for a longer periods of time. Okay, for the longer periods of time, here the most is the dominant noise, my dear students. Okay, most itself is the dominant noise. Most itself is the dominant noise, my dear students. And see here, when it is affecting for a longer periods of time, then it is affecting a system continuously. Then it is affecting a system continuously, my dear students. It is affecting a system continuously, my dear students. Okay, till that we have studied over these particular parameters in the last class, my dear students. Okay, now I am going to explain this particular concept, my dear students, okay, in a detailed manner. Okay, the noise that is created in the internal system. Okay, so what kind of noises that you are going to occur, let me depict you. Okay, see here, external noise I have finished in the previous class. Internal noise, the noise that is created inside the system, that will be in the form of thermal, or it is also called Johnson, it is also called resistor, or it is also called white noise, my dear students. Okay, it is also called white noise, my dear students. Okay, now what happens, how this noise occurs, let me depict you in a detailed manner, my dear students. Okay, good evening Kavita. Okay, for the new year session, okay, the first day, my dear students, hope that okay, you are going to enjoy in our respective channel, okay, in the coming new initiatives, everyone, my dear students. Okay, now see here, I am going to take it any sort, okay, any sort of the that is noise how is generating. Let me depict you in a detailed manner. Let me explain this particular concept in a detailed manner, my dear students. This is what, my dear students, I told you that how the power spectral density you are getting for a noise. I am going to explain each and every parameter, my dear students, over here. Okay, see here, my dear students, the noise, whatever the noise you are going to get over here, my dear students. Okay, listen carefully. See here, when I'm going to give the voltage over here, my dear students, then what happens? The noise is due to the random motion, okay, of what free electrons in the conducting medium, such as resistor. Okay, see here the random motion of the electrons in this particular conducting medium, my dear students. Okay, and these conduction electrons in the conductor can wander, okay, and these electrons can wander, my dear students. Okay, it is wandering, okay, entirely the volume of this particular conductor, okay, volume of this particular conductor, my dear students. As a result of that, what the received thermal energy, because they are going to give the voltage over here. When I'm going to give the voltage, what happens here? The more number of electrons are going to be moving inside this one. Okay, then what happens? There is a non-uniform distribution of the electrons takes place. One end the more number of electrons are there, and other end there is less number of electrons are there. Then what happens, my dear students? Then the non-uniform charge distribution takes place in this conductor. Then what happens? Non-uniform charge distribution takes place. My dear students. Non-uniform charge distribution takes place, my dear students. Okay, so here what happens? Here, because of that particular one, see here what happens at any instant of time. Okay, because the non-uniform, here more is there and here the less number of electrons are there, my dear students. Then what happens? Ultimately ultimately what happens, my dear students? At one point of time, okay, there appears a more here and there is a less. Okay, so then what happens? A potential difference is created. Okay, a potential difference that is created at the ends of this particular conductor, my dear friends. Okay, and because of this potential difference, because of this random voltage appeared, because what happens? I'm going to give more here. Then what happens? More power. Then what happens? Automatically the system breaks. More power means more power is dissipating. So that is generally the noise that is created. Here we won't get the sound. If I am going to tell you in a practical manner, my dear students, the noise, we can smell it. Internal noise means we can smell it, my dear students. Okay, if some wire is going to be, okay, burning because of the excessive power, how you can identify? You are going to identify with respect to the smell, my dear students. With respect to the smell itself. Okay, that is the noise because of the electronic circuits that is happening over here. Okay, that's what, my dear students. Okay, here what happens? Because of the excess of power dissipation, here the resistor is going to be breaking. Resistor itself is going to be breaking. So we are, which is acting here? The resistor. Here the resistor, my dear students, which acts as a noise source. Acts as a noise source, my dear students. Resistor is acting as a noise source, my dear students. Okay, and delivering a thermal noise power, and it is delivering what, my dear students? Thermal noise power. Thermal noise power, and that particular noise power is indicated by very important P, and it is N. Means this N is called noise and P is power, my dear students. Okay, thermal noise power, which is equal to K into T into B. Units are watts, my dear students. Units are watts, my dear students. Okay, watts. Okay, this is the noise power that is delivering, my dear students. Okay, this is what this one. Okay, here what is this one? What is K? K is what, my dear students? Boltzmann constant. What is K, my dear students? Boltzmann constant, and the value itself is 1.38 into 10 power minus 23, my dear students, joule per Kelvin, which is called the joule per Kelvin, my dear students. Okay, similarly, and here what is this? T is the temperature in degree Kelvin. T is the temperature in degree Kelvin, my dear students, and the bandwidth. Okay, B is the bandwidth of the noise spectrum. Whatever the noise you are getting, wherever the noise you are getting, my dear students, there a power spectral density is there. For every noise there is having a power spectral density. Okay, and for that particular noise power spectral density spectrum, the bandwidth also there, and that particular bandwidth is represented by, this is bandwidth in hertz. Okay, the bandwidth of the noise spectrum, my dear students, the bandwidth of the noise spectrum, my dear students. Okay, this is what. Okay, from these particular equation, my dear students, very important itself is that the ratio. Okay, the ratio, my dear students, of, okay, that is power by watts. Power Pn is watts and B is the bandwidth, my dear students. Okay, power, this is watts per hertz. ఎక్కడైనా నానా ఆల్రెడీ మనం చాలా ప్రాబ్లమ్స్ చేసాం. watts per hertz. Okay, watts per hertz is represented by the power spectral density. In some textbooks it is represented by Sn, and some textbooks is represented by N0. Okay, this is called the power spectral density, my dear students, or the power spectral density of the thermal noise, because of the thermal noise Pn by B equal to Kt. Okay, and this one itself is called power spectral density of thermal noise. Thermal noise, my dear students. Okay, which is the power spectral density of what, my dear students? Thermal noise. Okay, how many types of for any noise the power spectral density I told you in the previous class, previous recording slow, I told you, my dear students. Okay, how many types are there? There are two types of the power spectral densities, my dear students. One is called single sided. This is what? This is a single sided power spectral density, and two sided power spectral density, my dear students. Okay, very important one. Okay, this whatever the power you are getting, this is called single sided power spectral density, my dear students. Okay, now you got it, watts per hertz, how you are getting the units. Similarly, next one itself is the power spectral density. Whatever the parameter you are getting is Sn, which is equal to N0, which is equal to, my dear students, okay, Pn by watts per hertz, which is equal to, you are getting Kt. If I want to get the two-sided power spectral density, two-sided power spectral density is represented by N0 by 2, my dear students, N0 by 2, which is equal to P0 by, so what are the parameters you are getting is very important, 2b, or it is also called Kt by B, by dear students. Okay, this is what two-sided power spectral density. Two-sided power spectral density, my dear students. Okay, this one itself is okay. So now we got it, how you are getting the various terms, my dear students, over here. Okay, this is Kt, sorry, this is Kt by 2. Kt by 2, my dear students. Okay, is that clear, my dear students, up to here, everyone? Is that clear over here, my dear students, everyone? Okay, now here I am going to bring back such an equations over here. Okay, now see here, this see this. Okay, we are considering a noisy resistor. This is a noisy resistor, my dear students. For this particular noisy resistor, it is taking certain, it is driving certain load. Now what kind of parameters you are getting? Listen here, it is driving certain load, my dear students. Okay, consider this is a noisy resistor driving a load resistance RL, my dear students. Okay, now tell me what is happening over here, why this circuit is going to get the more power, excess power it is giving, because of on which principle this circuit is working? Thevenin's theorem? Is it Norton's theorem? Is it superimposition theorem? or it is maximum power transfer theorem. Why? This one is generating the excess power. What kind of principle does it is depending, my dear students? Thevenin's, Norton's, or superposition, or maximum power transfer theorem, my dear students. Okay, on which principle this particular noise is creating, my dear students? Can you give the answer over here? Yes, very good, very good, very good, Kavita. Because of the maximum power transfer theorem only, that is the definition lies in the name only. So here, what ultimately I am going to tell you itself is consider a noisy resistor. I am considering a noisy resistor driving a load. Very, very important formulas you are getting. Okay, driving a load, my dear friends, RL. Okay, according to the maximum power. Okay, that is transfer theorem, my dear students. Okay, as per the maximum power transfer theorem, now see here what happened, my dear students. A source of volts, because of this source only, see, because of this voltage only we are getting the here maximum power. Okay, so a source of V volts. So here, according to the maximum power transfer theorem, a source of V volts, okay, delivers a power of my dear students. Okay, what kind of power it is delivering, my dear students? Okay, very, very important. Okay, it is delivering, and that particular power is also very, very important over here, my dear students. Okay, as per the maximum power transfer theorem, generally the formula itself is Pn, okay, which is equal to, that is noise power equal to Vn square divided by R. But as per the maximum power transfer theorem, my dear students, Vn, okay, Vn itself we are going to take it is nothing but what kind of value is Vn by 2, maximum power transfer theorem. We can use this one, my dear students. Okay, therefore it is nothing but Vn square by divided by 4R. 4R, my dear students. Okay, you are getting in this particular fashion. Okay, this is the formula here you are getting over here from this. Okay, 4R. Okay, you are getting this one. Okay, but Vn square 4R is this one. But what is Pn? Pn equal to, you got it, K into T into B. Okay, so Vn square by 4 equal to, substitute Pn equal to K into T into B, my dear friends. K into T into B, my dear friends. Okay, then ultimately what you are getting over here, Vn square equal to 4R into K into T into B, my dear friends. Okay, 4R into K into T into B, my dear friends. Okay, this particular point you are going to get over here. You are going to get over here, my dear students. Okay, this is when we are representing resistances. Okay, so this is the thing you are getting, very, very important. Underline this one. Okay, similarly similarly, my dear friends, I am representing the power Pn equal to Vn square by 4R. Okay, Vn square by, okay, what are the parameter you are getting? Write down in terms of, my dear students, I square R, which is equal to In square into R by 4 in terms of I also. In term currents, I am going to take it in terms of currents. Later I am going to tell you, which is equal to K into T into B, my dear students. Okay, here also bring back In square. Okay, In square equal to 4 into K into T divided by R. The reciprocal of the resistance is what? Conductance. Okay, conductance, that is 4 into G into K into T into B, my dear students. Okay, you are going to get in this particular fashion. Okay, you are going to get in this particular fashion, my dear students. Okay, these are the parameters, means ultimately, okay, the parameters that you are going to get over here is very, very important. One is equal to Vn square in terms of voltages, which is equal to 4R into K into T into B. In terms of currents, In square equal to 4 into G into K into B, my dear students. Okay, these are the parameters you are going to get over here, my dear students. Okay, you are going to get over here, my dear students, as for this one. Okay, is that clear, my dear students? Up to here, everyone? Is that clear, my dear students? Up to here, everyone? Okay, Similarly, similarly, okay, similarly, see here, what are the parameters you are going to get is pretty important over here. Similarly, now how I am going to convert the noisy resistors into noiseless, okay, in series, and how I am converting a noisy resistor into noiseless in parallel, my dear students, okay, very important. First one is noisy resistors into noiseless resistors, my dear students. How we are getting the noisy resistors into noise, that is noiseless. First one I am going to depict you in series, then I am going to depict you in parallel, my dear students, okay, series and parallel, okay. Two important things just I am going to depict you over here. Suppose I am going to take it a, first one itself is series, this is what, my dear friends, I am taking the two resistors over here, my dear friends, noisy resistors in between A and B, okay. This is resistor 1 and this is resistor 2. This is NY stands for noisy, okay. Now I am converting these resistors in noiseless in series, okay. This I am going to convert in noiseless in series. Noiseless in series, my dear students, okay. This is what, this is A and this is B, my dear students. Converting into the noiseless, this is resistor R1, this is resistor R2, my dear students. When we are converting, you are going to get this one itself is very important. Very important, my dear friends, which is equal to Vn square. When you are converting here in series, you are getting the Vn square, Vn1 square mod, which is equal to 4R1 into K into T into B, which is equal to here V N2 square, which is equal to 4 into R2 into K into T into B, my dear friends, okay. These are the parameters you are going to get when we are getting the noise into noiseless, my dear students, okay. So these are the parameters you are going to get over here. Generally what happens, my dear students, if we want to get over here in this particular fashion, this is also very important, okay. If you want to get the complete, okay, complete ones also we can represent, okay. Later I am going to represent that particular thing also, my dear students, okay. If I want to calculate the noise voltage, the complete noise voltage, okay, the complete noise voltage is V n square, Vn square, which is equal to Vn1 square plus Vn2 square, my dear students, okay, which is equal to, see here, it is nothing but the addition of this one, okay, 4 into R1 plus R2, my dear friends, into K into T into B, okay. This is in series. If I want to calculate the, that is noise voltage, okay. Noise voltage means if you want to calculate the individual noise voltage means you can use across R1, across R2 means you can use the individual formulas, okay. Or if you want to calculate completely the noise voltage across the series means like this, okay. If you want to get across the parallel means there also it is changed, my dear students, okay. That also it is going to be changed, it is R1 R2 because the parallel itself is, okay, only noise voltage. If you want, if we want to get the noise voltage, my dear students, in parallel connection, which is equal to 4 into R1 R2 by R1 plus R2 into K into T into B. This is the things only for noise voltage. Okay, I am going to depict you these particular things in problems, my dear students. I am going to explain these particular concepts in the problems, my dear students. Okay, based upon this one. Okay, similarly. Okay, my dear students. Okay, very important over here. Okay, similarly, noisy resistance in noiseless. Okay, similarly, parallel noisy resistors in noiseless in parallel connection. Let me depict you. Noisy resistors in noiseless in parallel. In parallel, my dear students. You are going to use, my dear students, in parallel. Okay, what kind of the parallel things? Just I am going to depict you. Suppose this is in case of noisy resistors in parallel. This is R1. This is noisy resistor in R2, my dear students. Okay, this is parallel, my dear friends. This is in case of parallel, my dear students. Okay, this is R1. This is R2. This is noiseless now. Parallel connection. You are going to get what, my dear students? You are going to get the very important one, and that particular one itself is very important. Okay, what is that one? Currents in parallel. Parallel, my dear friends, which is equal to in1 square, which is equal to in2 square, my dear students. Okay, so already I told you this one in square formula ఇంతకుముందు వచ్చింది కదా. Sorry, already I have done, my dear students, in the previous case. 4g here, so here 4, this is for in1 square equal to 4, my dear friends, g1 into k into b, and this is n2 square equal to, my dear students, 4 into g2 into k into t into b, my dear students. Okay, like that you are going to get the currents over here. Okay, now if I want to get the complete current, in square equal to in1 square plus in2 square, which is equal to 4 into g1 plus g2, my dear students, into k into t into b. If I want to get the complete currents, my dear students. Okay, like that we are going to do over here, my dear students, in a such a fashion. Okay, now you got the formulas, my dear students. See, in series you are getting the voltages, in parallel you are getting the currents, my dear students. Okay, very very important one you need to remember over here. Okay, in this particular fashion. Okay, we have the 5 o'clock, one more important session is there, my dear students. Let me complete the one problem based upon this particular concept. Then you are going to follow it, okay, by the important announcement. Okay, my dear friends. Okay, similarly, so what, these are all the general things that I would like to bring it to your notice. Two resistors he has given, my dear students. One is 30 kilo ohms, another one is 50 kilo ohms, are at the temperature of 30 degrees centigrade. Okay, for a bandwidth of 1 megahertz, this determine the thermal noise voltage of each resistor, and resistors are connected in series and the resistors are connected in parallel, my dear students. Okay, he has given the question. No, it is 5 o'clock only, Kavita. It is 5 only, not 5:30. Okay, this is R1. R1 equal to R1 equal to 30 kilo ohms, and R2 equal to, my dear students, as per knowledge it is 5 o'clock only. R2 equal to 50 kilo ohms, my dear students. Okay, R1 equal to 30 kilo ohms and R2 equal to 50 kilo ohms, my dear students, and a temperature. Okay, and he has given the temperature is 30 degrees, converted to the Kelvin. Temperature 30 degrees centigrade, my dear students, which is equal to 273 plus 30 degrees. Okay, which is equal to how much you are getting, my dear students? You are getting these particular values 303. Okay, is it right? It is giving this particular voltage, my dear students, over here, which you are getting is 303, my dear students. Okay, so 30 degrees it is. Okay, degree Kelvin, my dear students. Okay, he has given this one. Okay, and the Boltzmann constant already you know what is the value. 1.38 into 10 power minus 23 joule per Kelvin. Okay, maximum we are closing the communications by the January 10th. No issues, my dear students. Okay, then after if there is any problems, I am going to explain you in the special classes, my dear students. Okay. Okay, this is what you are getting over here, R1 and R2. Temperature, my dear students, which is equal to 303, and Boltzmann constant. Now the noise voltage across each resistor. Okay, the noise voltage across this is R1. Okay, that is equal to V R1, my dear students. Okay, V R1. How much you are getting? Which is equal to under square root of under square root of 4 into 30, my dear students. Okay, R1 into, see here, 4 into R1 into K into T into B. Okay, that is T, that 0.38 into 10 power individual 4 R1. Okay, into, that is K into T into B. B equal to how much? 1 megahertz, 10 power 6, my dear students. Okay, this is the voltage across R1, my dear students. Okay, then you are getting very very important value, the voltage across R1. How much you are getting means 22.4 microvolts. Similarly, we need to calculate for R2, my dear students. R2, the voltage across R2, which is equal to 4 into 50. See here, we are going to take here also, my dear students, 30 kilo ohms. 30 into 10 cube here. Here 50 kilo ohms, my dear students. Okay, which is equal to 50 into 10 cube. 4 R into K. 1.38 into 10 power minus 23 into temperature. Okay, K into T into B. 1 megahertz 10 power 6. My dear students, okay, this is the voltage across R2. How much you are getting means 28.9. You are getting 28.9 microvolts, my dear students. Okay, like that you are going to get over here, my dear students. Okay, similarly, the voltage across the series. Series means I told you the formula. 4 into R1 plus R2 into K into T into B, my dear students. Okay, K into T into B means you are getting here 4 into, my dear students, R1 plus R2, which is equal to how much you are getting? R1 plus R2, 50 plus 30. Okay, you are getting how much? 80 into 1.38 into 10 power minus 23 into temperature, my dear students. You are getting the temperature also very very important. 303. Okay, into B 10 power 6, my dear students. Okay, you are getting the value approximately 36.5 microvolts, like that you are getting. Okay, similarly the last one, okay, which is equal to V parallel. V parallel, my dear students. Anmita Reddy, happy new year after a long time. 4 into R1 R2, my dear students, that is R30 into R50. So what are the parameters you are getting is 50 into 10 cube divided by 30 into 10 cube, my dear students, which is equal to 80 into 10 cube, my dear students. Okay, this is what you are getting over here. Okay, into K value. Ten power minus 23 K into T into 303 into 10 power 6, my dear students. Okay, you are getting in this particular fashion. Okay, then automatically you are getting the values, my dear students. 17.70 microvolts. 17.70 microvolts, my dear students. Okay, like that you are going to get, my dear students, over here. Okay, okay, my dear students. So today I am closing this particular session. Tomorrow's session is a very very important session, my dear students. Hope that the regular classes are going on in a similar manner, my dear students. Okay, please, okay, attend the sessions in a regular way, my dear students. Okay, finally the number of followers in the Facebook, okay, is increasing day by day as far as Unacademy is concerned. Not only in Unacademy and everywhere in Instagram and Telegram, everywhere the number of followers are increasing, my dear students. Okay, similarly Unacademy Telugu channel, you are going to access the subject in two languages, Telugu and English, my dear students. Okay, definitely Kavita, I am going to take it in app classes. I will definitely inform to you the practice sessions. Okay, similarly India's number one study channels are there, so where you are going to, okay, the different subjects for different languages, my dear students. Okay, for different subjects, my dear students. Okay, finally thank you very much, my dear students. Finally, thank you very much for attending the today's session, my dear students.